Hello viewers, welcome to Fraction TV. Keep watching, keep learning. Hey, remember, when it starts, don't touch that dial. Also viewers, kindly click on our subscription button to subscribe and make use of the comment section to ask for your chemistry e-notes containing likely questions and answers for your Neco 2022 examination. Thank you.
Good day, viewers. Welcome to Fraction TV. Keep watching, keep enjoying this particular channel. In this particular video, I'll be doing a big shout out to all my viewers, to everybody that have been enjoying this particular channel. I'm here because I'm interested in everybody's success. And in today's video, I'll be concentrating more on chemistry practical, NECO 2022. But before I proceed, I would like to introduce myself. I'm Mr. Francis, and I'll be taking us through the journey of chemistry practical. Now, I will advise my viewers to kindly click on the subscription button, make use of the comment section to interact with me in case you have any challenge or any question. Indicate by using the comment section. And also endeavor to share my videos because they are very important. Endeavor to share my videos because the more you share, the more you are touching life with them. In this particular video, I'll be concentrating more on chemistry practical. Like you all know, chemistry in NECO is divided into three sections. We have the theory, we have the objective, and we have the practical section. And in this video, I'll be concentrating more on the practical section of chemistry. In this video, I will not be performing any experiments, but I will only be taking you through the procedure or the principle of documenting your experimental work. Because I have found out that most students, when it comes to reporting of their practical work, most students are not actually good at it. Because of that, this video will be helpful in order to guide on how to report practical work. The practical in chemistry is divided into three sections. We have the volumetric analysis, which is also known as the titration. We have the salt analysis, and we have the general question. But in this particular video, I'll be concentrating more on volumetric analysis. I'll be concentrating more on how to report your experiments. Now, in your titration experiment, the following must be observed. Number one, ensure your work is what? Neatly presented. When you are representing your work or when you are presenting your work, ensure it is what? Neatly what? Written. That's number one. Number two, when you are reporting your work, ensure that your no cancellation or shading. Because anytime you cancel or shade, it will lead to the what? Deduction of what? It will lead to the deduction of what? Half mark. Now, when you are also reporting your practical work, ensure that the unit of measurement is indicated. Because when you indicate the unit of measurement, there will be an appropriate mark will be given to such a candidate. Now, I'll be moving straight on how to report your practical work. When reporting your practical work, the following must be noted. Number one, the indicator used. The indicator used for the experiment must be indicated. After writing the indicator used, the volume of pipette used during the experiment must also be indicated. There are two volumes of pipette. We have 25 cm³ and 20 cm³. Depending on the one you are using in your school, the volume of pipette must be what? Indicated. Now, I'll be giving a simple example on how to report your practical work and how to get your full mark when reporting your work.
Cool.
In this NECO examination for this year, the acid to be used is hydrogen trioxonitrate. The acid we are using for the titration experiment is HNO3, while the base is sodium trioxocarbonate 4. As a result of that, HNO3 happens to be a strong acid, while Na2CO3 happens to be a weak base. Now, the choice of indicator will be what? Methyl orange. Because when you are titrating a strong acid versus weak base. The choice of indicator will be what? Meteorage. Now, the volume of pipette I'm using for my experiment is 25 centimeter cube. After writing the volume of pipette, the next thing I will do is what? Burette reading. Under my burette reading, I have my final burette reading, initial burette reading, and volume of what? Acid use. Now, for the first titral value, my final burette reading is 14 and my initial burette reading is what? 0.0. Now, for me to get the volume of acid use, the volume of acid use is final minus what? Initial. Final minus initial. Now, my second titral value happens to be 17.60, the final burette reading, while the initial burette reading is 0.00. My final minus initial actually gave me the 17.60. And for the third titral value, the final burette reading is 13.80, while the initial burette reading is 0.00. My final minus initial gave me the what? Volume of what? Acid use. When reporting your experimental work, number one, indicator use must be what? Indicated. That is 1 mark. Number two, volume of pipette must be indicated. That is another 1 mark. Now, when I'm writing the volume of pipette, I did not only put the volume of pipette, I also indicated the unit. Writing the volume of pipette without the unit will lead to what? Deduction of what? Half mark. After that, I represented my table. During the representation of the table, shading is not allowed. Once you shade, it will lead to what? Deduction of what? Half mark. Make sure your work is what? Neatly what? Presented. Once your table is neatly presented, like what you have on the board, you will be entitled to what? 6 marks. Now, after that, I will move straightly to the what? Calculation of the what? Average titral value. How will I calculate my average titral value? Now, let me remind you. A reading is said to be consistent when the difference between them is plus or minus 0.20. Now, when I look at my first and my second reading, they are not consistent. Why? Because the difference between the second and the first reading is more than what? Is 0.20. Automatically, this second titral value will not be used because it is not what? Consistent with the first. Now, let us look at the differences between the first and the third titral value. When you look at the difference between the first and the third, the difference between them is what? Is 0.20. Automatically, these two values are consistent. Automatically, when calculating my average titral value, I will only make use of what? Consistent value. Now, when I say a reading is said to be consistent when the difference between them is 0.20. Now, when you look at the difference between the second and the third titral value, the difference between them is more than 0.20. Automatically, when calculating my average titral value, I will be making use of the first plus the third. The first titral value is 14. The third titral value is 13.80. After adding together, I arrived at 27.80 divided by what? 2. Automatically, for representing your average titral value, the candidate will be entitled to the 1 mark. The average titral value after calculating, it must be in what? 2 decimal places. The candidate is also entitled to another what? 1 mark. Now, after reporting your experimental work, the next thing you will need to do is to write the what? Equation of your reaction. Now, in this experiment, we are titrating. Our titration experiment involve HNO3 and Na2CO3. And when acid reacts with carbonate 4, it will produce salts, water, and CO2. Anytime acid reacts with carbonate 4, it will produce salts, water, and CO2. Now, after writing the equation of reaction, we'll balance up. After balancing, in this experiment, the mole ratio of acid to base is 2:1. How do I get the 2? The 2 at the front of HNO3 is the mole ratio of the acid. While at the front of Na2CO3, there is no number at the front. Because of that, the mole ratio of the acid to base is 2:1. Now, in this particular video, I'll be solving some of the likely questions to be expected in your Neco examination. Now, I want my viewers to kindly follow to understand the principle involved in solving the question. In this question, A is a solution containing 0.10 mole per gm cube of HNO3. Automatically, our acid in this question is HNO3. B is a solution of anhydrous sodium triazocarbonate 4. Anhydrous sodium triazocarbonate 4 happens to be our what? Base. Our acid in this question is HNO3 and it is titrated against B, which is anhydrous sodium triazocarbonate 4. The next question is, what is anhydrous salt? When we talk about an hydrous compound, an hydrous compound is a compound that do not contain what? Water for crystallization. And according to the instruction, they ask us to put A into the burette and titrate against 25 centimeter portion of B using mercury as indicator. Now, that means in this question, the indicator has been specified, mercury. Read the vol read the volume of your pipette, tabulate your burette reading, and calculate the average volume of acid used. I've actually performed this experiment, and I've also given you that the agricultural value that I'm using to solve is 13.90 centimeter cube. Now, from the equation of reaction has been given, HNO3 reacting with Na2CO3, it will give NaNO3 plus water plus CO2. Now, B, from your result and information provided, calculate the concentration of B in mole per dm cube. That means in this question, the first thing we'll be calculating is concentration of B, which is the base. B represents the base. Concentration of B in mole per dm cube. That means what the examiner is actually asking us to do is to calculate the concentration of B in mole per dm cube. Now, in this question, the concentration of A has been provided. We already know the concentration of A. Concentration of A in mole per dm cube has been given. The concentration of A in mole per dm cube is 0.10 mole per dm cube. Concentration of A has been given in this question. Now, as we know the concentration of A, the volume of A, which is the average titral value, has also been gotten after our titration experiment. Volume of A is 13.90 centimeter cube. The numbers of mole of A, from the equation of reaction, we can get the numbers of mole of A. The numbers of mole of A happens to be 2. The numbers of mole of A is 2. Now, they ask us to look for the concentration of B. Volume of B is the volume of the pipette, depending on what you are using in your school. According to this question, the volume of B has been specified to be 25.00 centimeter cube. Now, the numbers of base, numbers of mole of B, from the equation of reaction too, we can get the numbers of mole of B to be what? 1. The numbers of mole of B is what? 1. Automatically, we can make use of this formula since we are looking for concentration of B. CA over CB VB equals to NA over NB. CA, concentration of acid. VA, volume of acid. CB, that's what we are looking for, concentration of base. VB, volume of base, which is the volume of the pipette. Numbers of acid is gotten from the mole ratio. Now, that is why you need to write the equation of reaction. From the equation of reaction, we can determine the mole ratio of acid to base. Now, when you are performing your practical work, ensure to write the equation of reaction, because from the equation of reaction, you always get the ratio of acid to base. Automatically, we are looking for concentration of base. Concentration of base cross multiply. It will now be Ca times Va times Nb over Vb times Na. Make sure you report your work neatly, because that's what the examiner is actually looking for. 0.10, that's the concentration of the acid. Volume of acid is 13.90. the numbers of base is 1, the volume of base is 25, and the numbers of acid is 2. The upper part, what's the part? 1.39 divided by 50 is 0.0278. So therefore, molar concentration of B is equals to 0.0278 mole per dm cube. That's all. That's for the first step. Now the next question I will be solving is concentration of P in gram per dm cube. The second question is concentration of P in gram per dm cube. Concentration of P in gram per dm cube. We have two types of concentration. We have our molar concentration, which is measured in mole per dm cube, and we have our mass concentration, which is measured in what? Gram per dm cube. Automatically, the second question is talking about mass concentration. Automatically, our mass concentration of B, that's what we are looking for. Mass concentration of B will be molar concentration of B times molar mass of B. Mass concentration of B times molar mass of what? B. Now, from the first question, we've actually gotten our molar concentration of B. Molar concentration of B has been gotten. Molar concentration of B. From the first question, we've gotten the molar concentration of B, and it happens to be 0.0278 mole per dm cube. That is the molar concentration of B. The next thing I'll be doing is to look for the molar mass of B. B happens to be what? Na2CO3. Molar mass of B. And this representing what? Na2CO3, sodium triisocarbonate 4. Molar mass. We are looking for the molar mass of this particular compound. B is representing a particular compound, which is what? Na2CO3. The next thing I will do is to look for the what? Molar mass. Now we have 2 atoms of sodium, and the relative atomic mass of sodium is what? 23. 2 times 23. In this particular compound, we have 1 atom of carbon, and the relative atomic mass of carbon is 12. In this particular compound, we have 3 atoms of oxygen. Then the relative atomic mass of oxygen is what? 16. That means 2 times 23 is what? 46. Plus 12. Plus 3 times 6 is 48. Now, when we add everything together, 46 plus 12 plus 48 is 106. And the unit for our molar mass is what? Gram per mole. Unit of molar mass is what? Gram per mole. Automatically, the mass conc of B will be molar conc, which is 0.0278 times molar mass, which is what? 106. Automatically, the mass conc of B will be 2.946 gram per dm cube. That's the what? Mass conc of what? B. Remember that when I was calculating for the mass conc is what? Molar conc of B times molar mass of what? B. Next one, I'll be solving the third question. Given that B contains 3.60 gram of hydrated Na2CO3 in 500 centimeter cube of solution, calculate the percentage and numbers of molecules of water of crystallization in the hydrated salt. Automatically, in this question, we are looking for the percentage of water of crystallization and the numbers of molecules of water of crystallization. In this particular question, they've given us the mass of the hydrated salt. Mass of hydrated salt has been given in the question. Write out your parameters. mass of hydrated salt. Let it be clearly stated. Write out your parameters. Mass of hydrated salt is 3.60 gram, and they've also given you the volume to be 500 centimeter cube. The volume of the hydrated salt, the volume of Na2CO3 is 500 centimeter cube. Also given you the volume. They've provided you with the mass and the volume. Automatically, with this information, we can calculate the mass concentration of the hydrated salt. Mass concentration of the hydrated salt. The first mass concentration, the mass concentration that was calculated, the first mass concentration was for the first mass concentration is the mass concentration of the anhydrous salt. The first mass concentration that we got initially was that mass concentration is for the anhydrous. Now this second mass concentration will now be for what? Hydrated. Remember that when we are talking about anhydrous salt, we are talking about a particular salt that does not contain water of crystallization. Automatically in this question, we are looking for two mass concentration. The first mass concentration is for the anhydrous, while the second mass concentration is the mass concentration of the hydrated salt. Automatically, I will be calculating my mass concentration of hydrated salt to be the formula for the mass concentration of the hydrated salt will be mass of the hydrated salt over the volume in dm cube. Mass of the hydrated salt over volume in what? Dm cube. The mass of the hydrated salt is 3.60 gram and the volume is 500. We have to convert that 500 to dm cube by dividing by what? 1000. That means it will be what? 0.5 dm cube. 0.5 dm cube. That means our volume will now be 0.5. That means our mass concentration for the mass concentration of hydrated salt, the unit for the mass concentration of the hydrated salt will be in what? Gram per dm cube. Since our mass is measured in gram and volume in dm cube. The mass concentration of the hydrated salt will be what? 7.2 gram per dm cube. 7.2 gram per dm cube. That's the mass concentration of hydrated salt. But in this question, they did not ask us to calculate the mass concentration of the hydrated salt. What they asked us to calculate is the percentage. Calculate the percentage of water of crystallization. That is for us to calculate the percentage. Now, for us to calculate the percentage, please let us look at the board carefully. For us to calculate the percentage, the first thing we'll do is the mass of hydrated salt minus mass of anhydrous salt. Mass conc of hydrated salt minus mass conc of anhydrous salt. Now please let me give you a clue so that when you are solving, you will know what to do. Remember that the mass of hydrated will always be more than the mass of the what? Anhydrous. The reason why the mass of hydrated is more than that of the anhydrous is because of the what? Presence of what? Water molecule. The presence of water molecule has actually allowed the mass of the hydrated to what? Increase. Automatically, first thing we'll do is to calculate the mass conc of hydrated minus the mass conc of what? Anhydrous salt. The mass conc of hydrated is 7.2 minus 2.946. That's the mass conc of anhydrous. That means the mass conc of water. That means the water present in the hydrated will now be what? 7.2 minus 2.94 is what? 4.25 gram per dm cube. That means this 4.25 gram per dm cube is the mass conc of water. That means the water present in this particular compound. This is the dry salt. This is the mass of the dry salt. The water that has been added to this dry salt is 4.25 gram per dm cube. The next thing we will now do is to look for the percentage of water of crystallization. percentage of water of crystallization will now be mass of the water molecule, mass of water molecule over mass conc of hydrated salt times 100. That means for you to get the percentage of water of crystallization, mass conc of water molecule, this is the water present in this particular salt, this is the dry salt, this is the hydrated salt. Now when we remove the hydrated minus the dry salt, the leftover will be the mass of what? Water molecule. That means percentage of water of crystallization will now be the mass conc of water molecule, which is 4.25, the mass of hydrated, which is 7.2 times 100. 4.25 times 100 is what? Now, the percentage composition will be now be what? 59.02%. Is to look for the next thing I will be doing in this question is to look for the numbers of molecule of water for crystallization. For me to look for the numbers of molecule, this is the formula for looking for the numbers of molecule. Numbers of molecule of water will be mass conc of anhydrous, that is the mass concentration of anhydrous salt that does not contain water of crystallization, over the molar mass of anhydrous salt, the molar mass of anhydrous equals to mass conc of water molecule over molar mass of water. In this particular video, I will just be talking about how to calculate the numbers of molecule of water of crystallization in the hydrated salt. For us to calculate the numbers of molecule of water, we are looking for the numbers of molecule, we are looking for the amount of water present in the what? Hydrated salt. For us to get the amount of water or the numbers of molecule of water in the hydrated salt, this is the formula that is applicable. Mass conc of anhydrous salt over molar mass of anhydrous salt. Now when I'm talking about the mass conc of anhydrous, I'm referring to the mass conc of the salts that do not contain water of crystallization. Now the next one, it is equal to the mass conc of water molecule over molar mass of water. The mass conc of anhydrous is 2.946 and the molar mass of the anhydrous salt is 106 gram per mole. Now the next thing I will do is to actually look for the mass conc of water molecule. Mass conc of water molecule is the mass conc of hydrated minus mass conc of anhydrous. That's how I write that word, 4.25. And the molar mass of water is 18. 2 times 1 plus 1 times 16 is equals to 18. Since we don't know the numbers of water molecule present in this particular compound, the numbers of water molecule will now be represented by what? 18x. After that, I will cross multiply 2.946 times 18x, which is what? 53.0288x. 106 times 4.25, that is 450.5. Divide both sides by 53.028 and the value of x will be 8.4. And the value of s, which is the numbers of mole of water molecule, cannot be in decimal point. Because of that, we will round up to the nearest whole number, which happens to be what? 8. That means the formula for the hydrated salt will now be Na2CO3 dot 8H2O.